Okay, so let's talk about. So recently we just released a package. We call it machine learning quantum dynamics, but later on in the future we will also include other quantum dynamics methods in it. So this we incorporated the methods that I just presented there, this kernel ridge regression method, and then we have AIQD, and we have this OSTL method. So all these methods are there, and it's already available on the GitHub. So the link I just shared it there, and you can do the dynamics, the two-state dynamics using this package. You can also do this if more complex dynamics there. And what this package can do for you is it can propagate dynamics with the existing trained model. You just provide the trained model and it will do the dynamics for you. It can train the machine learning models for you, like the convolutional neural network and the kernel ridge regression model for you on your data. It can transform your data into the input files, X and Y. It can also do the hyperparameter optimization for you for both kernel ridge regression and the CNN model. It can also do auto plotting for you. And also the good thing is we implemented this we connected this MLQD package to MLATOM, and MLATOM is available on this SaaS cloud computing platform. So you can also use this MLQD on this cloud computing platform. So let me just talk about this cloud computing platform. So on our group, we have like these principal investigators. Like in 2021, we have started this because Professor Bebu, he has his own package for this valence bond calculation. We call it XMVB. Professor Fei-Feng Su, he has his own package for this energy decomposition analysis in Pablo Dral. He has his own package, the MLATOM, So they started to combine them on one platform. So they decided to also provide the cloud computing. So they called it SAGS, Shaman Atomistic Computing Suite. We also have some partners like Mario Prabhati and Alexander. And there in this cloud computing platform, you have these valence bond calculations methods there. You have these energy decomposition analysis package there. You also have MLATOM, where you can also use AIQ1 there, which is faster and more accurate than this DFT B3LYP, and you also can do geometry optimization. You can also do MD molecular dynamics, etc. So what we will do is I will just take you to first to the GitHub repository, and then I will take you to how to perform it on the cloud computing. So do you see my screen on this MLQD GitHub?
No.
No.
Okay, so okay, it should be okay now.
Yeah, now we can.
Okay, so here, this is repository. We have the packages here. There's a nice introduction here, the installation about dependencies and how to use it, some examples there. And we also provide some Jupyter notebooks there. If you click on it, there are some Jupyter notebooks. I just already opened those notebooks here. So you have these, you can just click on it and just open it. I'll just give you a quick tour here. So here you can see we have full detail of it, like Hamiltonian, how it's working, like what I am presenting, everything is here, how the data is generated and how we train it. And so everything is here. So you can use all, like for this FMO and for kernel regression model, we still like we provide it separately Jupyter notebooks, but here we will do our calculations on this computing, on cloud computing. So here, this is our SAIX website here. I will just share the link here in the chat. So this is a link, you can just click on it and then open it here. You can see we have XMVP here. You have this Zeta here, MLATOM here, XSCF here. So these are packages here. And then the calculation, the computation we do is you click on this computing, and then it just directly goes to this window here. You can click on it, which package you want to use. So we will be using MLATOM. The MLQD is actually, it has interface to the MLATOM. So we will click on MLATOM. And what we do is we will just put our input here, and then if there are some extra files, we will just upload it here and submit. So the manual for this tutorial is here. I will just share the link here in the So if you click on this link, you will directly just go to this tutorial here. This is a short tutorial, and these are different information about different parameters and arguments and what they can do. So we will just directly goes to, we also have a very detailed tutorial. If you click on it, it will just directly leads to the tutorial. So it's in more detail. So if you can see it, it has more details about the calculations and how the package works. But here we have we provide a short tutorial. And for the demonstration, we provide 20 trajectories by default. So if you don't provide your data, it still has 20 trajectories there. It will just grab those trajectories and perform the calculation. It's just for the sake of demonstration. So if you want to do the calculations, your own calculations, or you want to try other trajectories or data, you can get it from this database. So what we do is so let's train a kernel regression model. So what you do is you just copy this input and go to this SAIX website and just paste it here. And in this input, we are asking MLATOM to use MLQD, and this create a QD model, and the model should be kernel regression. And we are also asking to prepare input for us. And these are other parameters. And here we are telling the MLQD to the model is spin boson model, the two-state system, and how to save the model after training. So the model will be saved like this. And then when you submit it, you just go there. If you want to submit another job, you just click on it. If you want to see the job status here, you just go there, it's running. So it's running, we will wait, it will just run for 1 minute or 2 minutes. So here we will go back and submit another job. So we will go to so here you can see train a kernel regression model and then propagate the dynamics with the trained kernel regression model, the KR model. So here we are training, so we will not wait for it. When we get the model, we will just use that model to propagate the dynamics. So we will proceed to the next AIQD and train an IQD model. So we can use this input here and just copy it and paste it there. So here you will choose MLATM and then submit it. So we submitted the job and then we submit another job here. So we don't wait for AQD model, which will be just like training in the background, and then we proceed to the OSTL method, and then we train an OSTL model and copy it, and then you paste it and put the MLATM, click on MLATM, and then we just submit it. So what we see is our jobs are running. The first job is completed. You just click on download, and you just download it. So here, so I tested it yesterday, today, and also yesterday. So let me remove the old one. So we save it as a char, and then another one is running. So this one is also, this is OSTL, it's also completed. OSTL is quite fast, so it's quite quick. And the AQD is still running. What we can do is we can go back and perform some calculations with the trained models. So we will let's first use the kernel regression model to perform some calculations. So here in the kernel regression model, we need to provide a short-term trajectory. So we are providing this short-term trajectory here. It's a test trajectory, it's unseen to the model. So you can download it here, and then you need to upload it. So what we do is here, we copy this input, put it there. What we are doing is we are providing a time they propagate the dynamics up to 20, t equal to 20. And with this time step, 0.05. And we are asking it is like use QD model. Like while training the model, we were saying create the QD model. So here we are saying use QD model, and the model is KRR, and this is our short time dynamics, and the system is spin boson model, and this is our trained model we are providing, and this is the trajectory will be saved as a KRR trajectory. So, but to provide the trained model, we need to upload it here. So okay, so here it's uploaded, and then we also need to upload the short time trajectory there, the one we just downloaded from there. Okay, so we need to rename it. Okay, so we need to provide a short-term trajectory. Here we uploaded the short-term trajectory, and we will be using this trained model to propagate the dynamics, the beyond dynamics, the long-term dynamics. So we submitted, and here's it. It's already submitted, so we can see the job there. Okay, so our AIQD is also completed. You just download it.
Maybe it's too fast, and I don't know, like how many people actually trying to do this? So if if people trying to do and have some problems, you can interrupt and slow down, Arif.
No, I'm just showing to you. So later I
Yeah.
will come to you how to. If you have problem, I'll just what we are doing. So
Yeah, so please don't hesitate. Just write down in chat if you have question, or just speak. So unmute yourself. Maybe you can ask also what exactly you want to try out. Like I don't know, if there's a AIQD or try out on doing it on Jupyter notebook. So please let us know that we can just be more focused on one thing.
so the one here in the chat, Puchun, he also like you can use the notebooks on this GitHub on the Google Colab how to use it. Here he explained how to export it in the Google Colab and use it. So you can also use the standalone package there. You can use this cloud computing. So it's up to you. So you can ask question if you have any problem. So for this cloud computing, you need to make an account. So let me show you. I just logged it out. So you can just register here, click on it, register, enter your email, and you get your verification code. So you put your credentials here, and then you just register. So I already have an account here. So if you sign in, you just directly go there. And then you can go to my computing, and here I can see what the computation I so far run on this cloud server.